In this session, we'll be reviewing the concepts of DC motor drive. So, we have studied what a DC motor drive is. Simply a control arrangement that will be used, a configuration that consists of a power electronic device and a controller that can be used to control the speed or position of a DC motor is referred to as a DC drive. So, there are two power electronic devices that give us a DC output voltage. One is a rectifier and another one is a chopper. So using rectifiers and choppers, uh, how we can control, so we have actually studied the rectifier fed DC motor drives as well as the chopper fed DC motor drives. And rectifier fed DC motor drives, we studied. So as far as the rectifier fed DC motor drives goes, we have studied how using a half wave rectifier, uh, full wave rectifier, both single phase as well as three phase half wave and full wave rectifier at these RLE loads. We have studied how at different firing angles the motor will behave. Similarly, we studied using choppers, the class A, class B, class C, class D, and class E fed DC motor drives. We have discussed the desirable features of a drive. As far as the DC drives, DC motors are concerned, there are we mainly employ two methods, the field control strategy and the armature control strategy. By controlling the voltage and frequency of, by controlling the armature voltage output feeding the DC motor drive, we can control the speed of the DC motor as well as the position of the motor. We have studied the torque speed characteristics and the desirable torque speed characteristic profile of a DC motor drive. We know that uh, for an armature current which is continuous in nature, the speed fall will not be much uh, as the load change, but wherein we have a discontinuous armature current, the speed fall will be more rapid with change in load. Fine. So if the armature current is continuous, the variation in speed will not be much significant. If the armature current is discontinuous, there will be a significant amount of variation in the speed as load changes. So we can, so we have studied for different uh, modes, for continuous conduction modes, for discontinuous conduction modes. With as far as the chopper goes, it's much easier to maintain a continuous conduction mode as that's as compared to a rectifier. So we can avoid a discontinuous current by adding an inductor in series with the armature or by raising the chopping frequency. And as far as the closed loop control is concerned, this discontinuous current can be actually easily uh, taken care of by the closed loop control. So the DC drive is fairly simple. There is not much to it. Uh, it has an inherent torque and flux uh, independency. That means the torque and flux are not dependent upon each other. As already stated that uh, flux flux control is sluggish. The DC drive is fairly simple. There is a inherent torque and flux decoupling. Uh, as, as said earlier, flux control is sluggish, while as we want a dynamic, a robust, more robust torque oblique speed control. Uh, so since there is an independency between flux and torque in case of a DC motor, so the drive is fairly simple. Now, as far as the AC drives go, they are not much inherently, they are not as simple as the DC drives. There is a coupling between flux and torque. So, that coupling between flux and torque is basically a disadvantage in the case of AC drives. So, that was the reason why DC motor drives were preferred uh, in the mid 1900s. Uh, for a long duration of time, the DC drives were uh, finding much more use as compared to AC drives. But with recent advancements in semiconductor technology, with control strategies, it's become possible to control AC drives in a similar fashion to that of DC motor drives. So there is an advantage of decoupling can be associated now with an AC drive as well. That's not a inherent but a forced decoupling. So we'll be studying the AC drives from the next session. So this was just a recap of DC motor drives. We have studied the DC drives, we have studied the rectifier for DC drives, the chopper for DC drives, we have studied the desirable features of a DC drive. We have seen that a DC drive is fairly simple. It's robust. There are a lot of applications wherein a DC drive is employed, such as in trams, in trains, in small pumps, in robotics, and many other applications. Uh, we have studied the we have studied the control strategy of a DC motor drive, where we studied the three loop control, the current loop control, the speed loop control, and the position loop control. So that's all about the DC motor drives. Uh, and from the next session, we'll be taking up the AC motor drives. So current loop can be used to control the torque of the motor as well. So that's all about DC motor drives.